Hello folks, Larry here again from Curio Mechanics. Today we're going to take a look at another piece of technology from history that helped make some incredible things possible. It's called core rope memory and was developed in the 1950s and used originally in UNIVAC 2 computers. In certain applications, computers are subjected to some pretty harsh environments and need to be absolutely reliable, regardless of the bad things that are happening to them. One of those applications is space travel, specifically traveling over 250,000 miles to the moon. The computers used in the Apollo space program were bombarded with radiation, as well as other completely unknown influences, and had to perform perfectly to keep the crew alive and in the correct position in space. For the solution, NASA turned to Raytheon to use an existing technology known as core rope memory. So what is it and how does it work? Let's take a look. Computers operate by having different wires turned on and off and interpret these as either ones when the wire is on or zero when the wire is off. In most computer components, these bits are stored by capturing a small amount of electricity in a cell that can later be read back to determine its state. This works fine in most situations, but, like I said, the space program offered greater challenges of being exposed to positively and negatively charged particles which could disrupt the state of these storage cells. The clever solution that core rope memory offered was to literally run wires through magnets that altered the flow of current when being read. This means that physics itself determined which bits were read as ones or zeros, and it was very resilient. What made it challenging to use was that each line of data had to be physically woven through a series of circular magnets to create each bit and byte of information. This work was done by a very skilled team of mostly women who had to painstakingly translate each line of code into the pattern that the wire followed in and out of the magnets. The code they were working from was written at MIT, and Raytheon handled the manufacturing for all of the modules used in the Apollo navigation systems. It had to be done absolutely perfectly, as there is no way to change the information once it had been woven. While even at the time, microchips could be reprogrammed, once the wires were formed into their paths, that was permanent. This also meant that the code and stored data had to be bug and error free. Any mistakes in the software could send the astronauts into an unrecoverable error, or worse, cause subtle navigation errors that could go unnoticed until it was too late. NASA obviously had many checks and balances in place to ensure no one system could derail the entire mission. But any failures in the electronics would have posed a greater threat to success and safety. There were other industrial applications for core rope memory, but to my knowledge, none of them continue to be used today. The size and weight of the system have made it prohibitive to use on current space projects. Besides going to the moon, core rope memory was also used in early Mars probes. It proved to be a reliable and satisfactory system for hardening our intrepid Voyager's electronics. Per cubic foot, the core rope memory was able to store 72 kilobytes, which was far more dense than its competing magnetic core RAM, which was only able to store 4 kilobytes per cubic foot. In today's age of nanometer manufacturing, I thought it would be interesting to highlight a process that was literally built by hand, weaving each pattern of ones and zeros into a physical wire. The people who developed and built these systems pulled off a flawless execution of a system that allowed for no mistakes whatsoever and allowed several important NASA missions to succeed. I personally appreciate their hard work and dedication to perfection. I hope you enjoyed this short look into this amazing technology. If you're new to the channel, please consider subscribing. All engagement is welcome and help grow the channel. Thank you for watching, and I hope you enjoy your day.